So Leetcode 11, container with most water. You are given an integer array height of length n. So we have n elements in 1D array, 1D container. There are n vertical lines drawn such that the two endpoints of the ith line, okay, so we have lines, and each line has two endpoints, bottom and top, and the bottom one is I and 0, and then the top one is I and height at index I. And so basically what they are saying is that we have n sticks, some of them are short, some of them are long, and to get the length of a given stick, we have to go to height array and take the corresponding element. And what do they want from us? We have to find two lines that together with the x-axis form a container, such that the container contains the most water. Okay, so when we take any two sticks, a pair of sticks, and x-axis, we can form a rectangle. And the area of that rectangle is what we are looking for, and we have to find the rectangle with the greatest area for any combination of sticks and return the maximum amount of water a container can store. So what they want from us are not the indices of those sticks which form the greatest rectangle, just the area itself. Notice that you may not slant the container. And here is an image for the first example, which is always good. An image is worth 1,000 words. So let's see. An input height has the following elements. First is 1, and this is the shortest stick, then 8, much longer, 6, 2, 5, and so on. So those are our heights, and they have marked with red color two rectangles or two sticks, which together form the greatest area. So the output is 49, and that's the area of the blue rectangle. And you might get an idea, for example, to just take the longest sticks and find the area between them. But as you can see on that already on that first example, that's not always the case. So for example, this is a longer stick than that, but if two longest sticks are close together, the area between them might be less than the area between some shorter sticks, which is further apart. And so you always have to take into consideration not only the height or not only the distance, but both at the same time. So we always have to compute the area itself. And that's more or less it. So for example, the second example has just two elements, so it's just given like that. For the sake of it, there is nothing we can learn from that because we have only one option, and in that case we have to take those two sticks because there is no other option. So let's draw that in detail and think about everything that we may need in order to come up with some efficient solution. So we've mentioned areas. The first question that we have to answer is how to compute an area between a pair of sticks like that. That's our first question. I might make it a little bit bigger. Then the second one is how to find the greatest area. So we need a formula to compute an area between two sticks, and then somehow we need also a way to traverse the sticks and find the greatest area. And we may even mark it as like a search goal. So how to move through the sticks. So those are our goals. I can even mark it as goals for now to keep in mind. Like that. And now let's draw a stick of some length and another one, which we will make a little bit shorter. Put it like this with some distance between them. And we can add x-axis like that. A little bit smaller like that. Here is our x-axis. So those are randomly chosen two sticks. One of them we call A on the 8th index, and another one on the bit index we call B. And where is the area? Where is this water between them? We may draw it like that. Here is the water. Let's mark it with some lines inside. And the first important thing is that we have to take the length of the shorter of two sticks, because if the water would be above it, it would overflow, and that's not allowed. So whenever we will compute the area of the rectangle, we take the width, we take the height, and the height is the height of the shorter stick in our pair. So let's call height h. Let's call width w. And the area at equal to h multiplied by w. And that's the formula for a rectangle. And in our case, h is the minimum between height A and height on index B. Because we don't allow the overflow, so that's our height for any pair of sticks. And our width is simply the distance between B and A, so B minus A. Well, that's already the heart of the solution that we have. Let's mark it here like that. And how to find, so that would be the first goal. We may move it here like this. That's already solved. So let's put it here and here. The second goal is how to find the greatest area. We need to store max area found so far. And each time we compute area for the new pair of sticks, we simply update max area if the area is greater. So initialize max area with some small number like -1. And that's a common thing for a lot of Leetcode problems. So, for example, the longest increasing subsequence or something like that, you would always have some counter. And first, you initialize it with some extremely small number that you will not find actually in the cases that they will give you. And then you update it as you go. So you take the first area or the first whatever you are computing, and every time you compare the one that you computed right now in a given iteration with the one that you have found so far. So you start with some small number and then update whenever a new area this is greater than max area so far. And so you would do like that, and that's our second thing. And the last question, we've already mentioned that we will have two indices, A and B. Start A at the beginning of the array, and put B at the end of the array, and after we get the area between them, shift 1. And in that case, we will have start in the beginning with A would be at the very beginning of the array, B would be at the very end. We compute the area for the first pair of sticks, then we move, and so on. And we will get all the areas. And in that way, we can find the greatest area. Between them, shift 1. Okay, good. So let's put those thoughts into code. So let's start with A equal to 0. Those are our indices. B equal to length of height minus 1. Yeah. So first B would be at the end. A would be at the beginning. And we need max area, which will first initialize as minus 1. And while A is less than B, we can compute the area. So H is the minimum between height of A and height B. The width is simply difference between them. Yeah, so B minus A. And the area itself is H times W. Yes. And now we check the new area is greater than the max area that we have found so far. If so, we update the max area. And the last thing we have to do, we have to shift one of our sticks. So we always shift the shorter stick. If height of A is less than height B, A plus equals 1. So we move A to the right, and we move otherwise B minus equal to 1. We move B to the left. And at the end, we can return maxed area. Let's run and see if I haven't made any syntax errors, something like that. Wrong answer, let's see. A. Yes, I see. I reused A for the area itself. So let's not make that mistake. And let's run it again. There was a conflict between the names. Let's submit. And we are faster than 80% of the solutions. There are probably some optimizations we might do, but I guess the main idea has been implemented.